Welcome back to my channel. How are you doing? Today's topic is the binary tree. Let's take a look at what we'll cover today. We will start with an introduction to what a binary tree is. Then, we'll explore tree traversal methods, starting with pre-order, followed by in-order, and finally, post-order. At the end, we'll cover how to quickly count the leaves in a binary tree. So, let's dive in and explore what a binary tree is. A binary tree is a type of data structure that consists of nodes. Each node can have up to two children, known as the left child and the right child. This structure is distinct because each node can have 0, 1, or 2 children only. Let's examine some trees to see if they are binary trees or not. Look at this tree. Is this a binary tree? Think about it. Remember, a binary tree is defined by each node having at most 2 children. So, is this tree a binary tree? If you said yes, you're correct. Since every node here has at most 2 children, this indeed qualifies as a binary tree. Now, let's move on to pre-order traversal for binary trees. In pre-order traversal, as demonstrated here by AlgoSheep, the order of traversal is crucial and must always be followed. We start from the root, then move to the left node, and finally to the right node. Let's look at an example to understand this better. We start at the root, which is 3. Next, we move to the left node, which is 12. Since 12 acts as the root of its subtree, we continue our order by first moving left to 6. After visiting 6, we then go to 8, which is on the right side of 12. Next, we explore the right side of the main root. We start with 11, which acts as another root. First, we traverse to the left to visit 24, then to the right to see 1. Having completed the traversal of both the left and right sides of the tree, we have followed the pre-order sequence: visit the root first, then the left subtree, and finally the right subtree. This systematic approach helps us cover all nodes of the tree efficiently and in a specific order. Now let's move on to in-order traversal. To illustrate the differences clearly, we'll use the same example as before. In in-order traversal, the order is left node first, then the root, and finally the right node. This sequence changes how we traverse the tree. Starting with the leftmost node, we begin at 6. After visiting 6, we move up to its root, which is 12, and then proceed to 8, which is to the right of 12. Having completed the left subtree of the main root, we now visit the main root itself, which is 3. Just like on the left side, we approach the right subtree by visiting the leftmost node first, which is 24. After 24, we move up to its root, which is 11, and finally, we visit 1 on the right of 11. This methodical approach shows how in-order traversal differs. It ensures that we visit each node in ascending order when the binary tree is a binary search tree, providing a natural sorting mechanism. Now let's move on to post-order traversal. Remember, in post-order traversal, we start from the left node, then move to the right node, and finally visit the root. It's important not to mix this order up. Let's apply this to the same tree we've been using to illustrate the differences clearly. Just like in in-order traversal, we start from the leftmost node, which is 6. However, instead of moving up to the root next, we first go to the right node, which is 8. After visiting 8, we then move up to their root, which is 12. This completes the traversal of the subtree rooted at 12. Next, we need to handle the right subtree before we can visit the main root, which is 3. In the right subtree, we start with the leftmost node, which is 24. After 24, we move to the right node, 1. Once both children have been visited, we move up to their root, which is 11. After completing the traversal of both subtrees, we finally visit the main root, which is 3. This completes our post-order traversal, where each node's children are visited before the node itself, ensuring we always end at the root. Today's final topic is how to count leaves in a binary tree, which is actually quite simple. A leaf in a binary tree is any node that doesn't have any children. To count them, you simply identify and count all such nodes. Take a look at this example tree. Notice the nodes that don't have any children? These are our leaves. In this tree, there are 4 leaves. It's very easy, right? That's all for today. Thanks for watching. If you found this helpful, please give it a thumbs up and subscribe. Any questions or requests? Comment below. See you next time.